Since we only have 8, I think I'm going to go by units of 20 to get all the way up to 110. Okay, so labeling our axis, unemployment rate, and then this is cumulative frequency. So how the axes are labeled is really important for you to know what's going on in this graph. So looking back at my table, between 0 and 3 is a cumulative frequency of 9. Since our units have changed here, we just need to make sure here is 10, so just below it would be 9. Between 3 and 6 has a cumulative frequency of 53. Halfway between 40 and 60 is 50, and then about halfway is 55. So then somewhere in the middle there would be 53. Between 6 and 9 is 79, so that's just below 80. And I'm kind of guessing on where these dots go, trying to educated guess placement. Go ahead and continue filling out your dots. I will do it silently here. You can do it then and double check what you've got going on. Again, connecting linear, no curve, because we don't want to insinuate that there could be a decimal input here at all. We're just talking about points of data. Also notice that the data stops, right? At the end of our graphs, there's no continuing on. There's no arrow to the right. It's because when we stop there, when we put that data there, there is no more data. There is no more insinuating that there is more data. That is the end of the data, so that is all we can graph. Now notice with the frequency graph, it's really easy to tell where the bulk of our information is because it's where the tallest part of the graph is. Here, the tallest part of the graph is when we get to the very end, which is 110 people, right? So we've then tested all of the people. So how we know where the bulk of our information is we have to look at the slope of your curve. So the slope here, the steepest slope you can find is going to be where the bulk of your information is, where the most of your information is. So here is probably going to be between here and here where your largest, I'll do like a little squiggly, where the largest amount of your information is. That is your kind of shift of focus on cumulative frequency graphs, is if you want to know where most of the data is, where most of your people lie, you have to look at how steep the graph is. The more steep it is, that means you had a big difference between here and here. You added a lot of people, so your slope is really steep. Whereas here we start to taper off, it's because we're only adding like 1 or 2, so it's really starting to flatten out. So the bulk of our information is here, and then we just get to our total at the end. Okay, let's go ahead and practice. We've got a few examples. We have a cumulative frequency graph here. So we notice that, so for instance, if we're trying to figure out where the bulk of our data is, we can see, first of all, we're talking about speed of cars. Busy intersection, the speed of passing cars is recorded, and the information is represented in a cumulative frequency graph. So we've got speed of cars and cumulative frequency. So this is how we get up to. We don't have a lot of information at the beginning, but towards the middle, we tend to have a lot of information. So I would say between here and here, how I know it's a lot of information is because the curve is steeper, right? So most data is represented in between these two squiggly marks. And then it tends to taper off again, so we don't have as much data in this range. The first question here, it says, how many cars were included in this sample? So remember, up here, we included a total of 110 countries. So when we entered the data on a cumulative frequency graph, we entered the data at the total amount of people that we studied, or countries that we studied, which was 110. So Mimicking that down here, we need to go to the end of our graph. And the end of our graph is right here. Now, this is speed of cars. This is total number of people or number of cars that were studied. I'm going to use a ruler to try and figure out or follow the line that goes back. And it looks like the line that goes back for us is 5150. So I'm going to say 50 cars. So I went all the way back here and said, hey, it was at 50. And that is the total of number of cars that we studied because we're cumulative. So we're adding on till we get to the very end of all of the cars that we studied. The speed limit at the intersection is 40 kilometers per hour. Remember this -1, anything to the -1 is 1 over that thing. So kilometers space h to the -1 equals kilometers divided by hours. So kilometers per hour. So it's just a speed. The speed limit at the intersection is 40 kilometers per hour. How many cars were driving at or below the speed limit? And what percentage of the cars is that? So we're talking about speed. So go to the axis that represents speed. That is your x-axis. Find 40. It's right here. This graph already drew in the line for you to follow, which was really nice. So we follow that line 40 all the way up till we hit the graph. This is the point on the graph that represents 40 kilometers per hour. So we follow that then to our y-axis. And our y-axis here at 29 says 29 cars, the things that we are counting. 29 cars were at that speed limit or below. If we wanted to find at that speed limit or above, we would then have to take 29 and subtract it from 50. So we are at 29. If we're talking about what percentage of the cars total is that, we take 29 and put it over the total number of cars that we studied, which was 50. 29 divided by 50 is going to give us a decimal. We multiply that by 100 to get a percent, and that's 58%. Over half, but just barely, over half of the cars were at the speed limit or below, which is pretty good. However, if a car is traveling more than 10 kilometers per hour above the speed limit, they receive a speeding ticket. How many cars should receive a speeding ticket? So more than the speed limit, which is 40, 10 kilometers more than that is going to be 50 kilometers per hour is a speeding ticket. So with our speeding ticket or with that 50 kilometers per hour, I'm going to do what we did here, but on my own because we don't have a line. So I'm going to go to where speed is represented on the axis, which is on the x-axis. I'm going to follow that line up to here. I'm then going to follow that line to the y-axis. Following that over here gives me 42. So 42 cars, but this is 42 cars were either at 52 or below, at 50 kilometers per hour or below. So if we wanted to know at 50 kilometers or above, at 50 kilometers or below. So if we wanted to know at 50 kilometers or above, we would then take 42 and subtract it from our total number of cars. Our total number of cars is also 50, which can be confusing with the speed. So 50 cars minus 42 cars equals 8 cars. 8 cars could potentially be in danger. Since technically at 50 kilometers is not more than 50 kilometers, so maybe that car won't get a speeding ticket, but we don't know for sure. So potentially 8 cars would receive a speeding ticket from this data collected. The slowest or 10%, the slowest 10% of all drivers are seen as a safety hazard and are also issued a fine. What is the maximum speed considered to be a slow safety hazard? So first of all, 10% of all drivers. So we want to find 10% of the total number of cars that we looked at, which is 10% of 50, which means that we take 50 and we multiply it by 0.10, which is 5. So we're talking about the 5 lowest cars on the speed range, which means that we're looking at the bottom of our range. So we're talking about here at 5. If we wanted to talk about the top 10%, we would then have to take 5 and subtract it from 50 to get to the top, the highest speed. We're talking about the lowest speed, so we're going to be down here. If we wanted to talk about the highest or the greatest speed, we would be talking in the top 5. So that's kind of where context comes in, that you have to make sure that you know what you're looking for. So 5 cars, we go ahead and follow that line to the graph and then follow it down and look at where it's at. It's halfway between 14 and 16, which means we are at 15. 15 kilometers per hour is the maximum, right? Because it's 15, you could be at 14, 13, 12, 11 kilometers per hour, and all of those would still be a safety hazard. So this is the maximum speed you can have in order to still be considered a safety risk. So you'd have to be above 15 kilometers per hour in order to not be a safety risk. So 15 kilometers per hour is the maximum speed considered to be a safety risk.